Question 5 from the AIHL exam is here on the left, which is identical to question 9 from the AISL exam. So following recording is my answer to question 9 from the AISL exam. Question 9. The graph below shows the average savings $1,000 of a group of university graduates as a function of T, the number of years after graduating from university. Part A asks, write down one feature of this graph which suggests a cubic function might be appropriate to model this scenario. Okay, so we have a few features that we could use to suggest that this is a cubic function. We only need to state one though. I'll tell you the three. So the first one, most obvious, will be perhaps that there are two turning points. There is a maximum and a minimum. Additionally, so another feature would be that there are three x-intercepts. That's typical of a cubic function. And lastly, there is only one point of inflection, which would be roughly around here. Okay, so any one of those features would be adequate to answer part A. You only have to use one, so I'm going to go with the turning point idea. So I'll just write down here. We'll say there are two turning points. We'll say a maximum and a minimum. Okay, and then, yeah, to state again, you could also say that there are three x-intercepts or that there is one point of inflection, and those would be adequate as well. Right, let's move on to part B. So the equation of the model can be expressed in the form S is equal to AT cubed plus BT squared plus CT plus D, where A, B, C, and D are real constants. Okay, let's highlight that because we'll definitely need that. The graph of the model must pass through the following 4 points. All right, so from this table. Part B1 asks us to find the value of D. All right, now when we look at our function here, okay, D is effectively representing the y-intercept here, okay? Because if t is equal to 0, effectively this AT cubed bit is going to be equal to 0, so there's nothing there. The BT squared bit is going to be equal to 0, so there's nothing there. CT is also going to be equal to 0. So we'd just be left with D, okay? And yeah, so that's when t is equal to 0, S is going to be equal to 2D effectively. And we get that from the first line here, okay? We have that here, okay? So when t is equal to 0, S is equal to -5. And from what we just saw, right, that means the A bit, the B bit, the C bit, they're all just going to equal 0. And we're going to get 0 plus 0 plus 0 plus D is equal to -5. And so therefore the value of D is going to be -5. So if I sort of write that out down here, okay, we'll have B. If we said, S, let's say, and we'll write in sub, T is equal to 0 and S is equal to -5, all right, from this first bit of the table, okay, and we'll do that. We'll say S is -5 is equal to A multiplied by 0 cubed, which is just 0, plus B times 0 squared, which is also going to be 0, plus C times 0, which is 0, and then plus D. Okay, and so therefore we get D is equal to -5. Okay, and so there is the answer to part BI. So I should probably We'll bring this over and we'll put part I or part 1 in there. All right, let's move on to part 2. Hence, write down 3 simultaneous equations for A, B, and C. Okay, so that's going to be using these next 3 sort of values we're given here. Okay, so if we substitute in t is equal to 1 into this, into our equation or our model for S, we'll get sort of A multiplied by 1 cubed, which is just A, plus B times 1 squared, which is just going to be 1 again, so it's going to be B, plus C times 1, which is C, plus D, and we have that equaling to 3. All right, so that could be our first one. And then subsequently, we're going to go through this. We're going to substitute 2 in for T in each part here, and then get a different coefficient for A, B, and C, and that's going to equal -1. And then we're going to substitute in T is equal to 3 into our model, right? And then we're going to get then again a different coefficient for A, B, and C, and then that is going to equal -5. All right, let's go do that. And here we'll say the 3 simultaneous equations for A, B, and C. Yeah, cool. All right, so so our first one is when T is equal to 1, S is equal to, now I've gone 3. All right, and so then we also have, so we'll write that in here. We've got 3 is equal to A times by 1 cubed, so A multiplied by 1 cubed, plus B times by 1 squared, plus C times by 1 plus D, which we know is -5, so we can just put that in, -5. So therefore, we're going to have 3 is equal to A plus B plus C -5. All right, so there's our first equation. And then now when we move on, we're going to say when T is equal to, was it 2? And S will be equal to, we got -1. Okay, so now we can go through and do that. We'll say -1 is going to be equal to A multiplied by 2 cubed plus B multiplied by 2 squared plus C multiplied by 2 -5. Now, if we work through this, we're going to get A multiplied by 2 cubed, which will give us 8A. Let me clean that up. That's not very good. And then moving on, we're going to get B multiplied by 2 squared, which is going to be 4B. And then lastly, we're going to get 2C -5. All right, so there is our second one. So let's just, we'll label these. This is our first equation. This is our second equation. Am I going to run out of room? Most likely. We can add a new page there. That's right. And then now let's find our third one. Okay, so this is going to be when T is equal to 3 and S is equal to -5. All right, so let's bring that down. When, and I'm just going to be somewhat lazy and use this. Is that going to work for me? Yeah, there we go. When T is equal to 3, S is equal to -5. Okay, and so we'll go -5 is equal to A multiplied by 3 cubed plus B multiplied by 3 squared plus C multiplied by 3 -5. And now if we clean this up, we're going to get 3 cubed is 27. So we'll get 27A. 3 squared is 9. So we're going to get 9B plus 9B. Then plus 3C -5. And that is our third. Okay, so there is the answer to part B2. Let's move on to part 3. And so we are asked to hence or otherwise find the values of A, B, and C. Now, the best way to do this is to use your GDC, your graphics display calculator, to solve these simultaneous equations. If you are unsure of how to do that in your specific or particular calculator, give it a Google, research. Just Google the model of your GDC, the calculator that you have, and then followed by systems of linear equations or how to solve simultaneous equations with 3 variables as well. I have to write that in, and there should be a YouTube tutorial or a little manual that will run you through how to do it with your specific model. However, I have this calculator here, Symbolab, which can do systems of linear equations for me. I will also mention, otherwise, you can use matrices to solve this, though matrices aren't involved in the AISL course. So yeah, the best way would be to learn how to do this. So learn how to do this in your particular calculator. So let's go into split view for this, so it's not so small. And we'll put in our 3 equations, and it'll spit out a value for A, B, and C. I will also stress, or I will just note that for each of these 3 equations, you could have also brought the -5 to the other side of the equation. So, for example, equation 1 would have been 8 equals 8 plus B plus C. Equation 2 would have been 4 equals 8A plus 4B plus 2C, and equation 3 would have been, what have we got? 0 equals 27A plus 9B plus 3C. Both would have been fine. So let's go without further ado. Let's plug these in. So we've got 3 is equal to A plus B plus C. Right, separate these out with a comma, and then we have -1 is equal to 8A plus, what have we got, 4B plus 2C. I've got to put in the -5, both of these. -5, and that comma in, -5, right, and then again, space, -5 is equal to 27A plus 9B, 9B plus 3C -5. Right, now I'll click go, and that gives me the 3 values, weirdly in the order of A, C, and MB. Slightly odd, but anyway, that's the way that my calculator does it. Yeah, once again, if you are unsure of how to input that into your own specific calculator, then just give it a look, and your calculator should be able to do it. We'll definitely be able to do it. If it's a GDC available for these, or allowed for these exams. Okay, so let's put that in. What do we have? A is equal to 2, B is equal to -12, and C is equal to 18. Okay, slide over. Okay, part BII, or III, sorry, I should say. A is equal to 2. B is equal to -12, and C is equal to 18. Okay, lovely. Let's move on to part C. Right, so now we have to, a negative value of S indicates that a graduate is expected to be in debt. Okay, use the model to determine the total length of time in years for which a graduate is expected to be in debt after graduating from university. Okay, so if we go back up to our graph here, essentially what this question is asking us to find is the total amount of time that this graph is below the x-axis or the t-axis, if you will. Okay, so that is essentially, that's this time here. So how long is that time there? And then also how long is this time here? All that there. Okay. And so the way we're going to find that is by, first of all, finding the x-intercepts for our function. Okay. And then we're going to take this x-intercept, and so say take that and then add in the time which is from here to here. Okay, so there's a bit of maths involved, but we will also have to graph this function in our calculators. You don't have to, but that would be the most efficient way. So let's go and do that. So let's we'll bring our calculator back over, and I'll go into split view again. Right. And so now I'm going to change the variables of s into y and then t into x, just so that the calculator recognizes that I want it to graph on a y and x axis, or xy axis. And so yeah, let's do that. So we got y is equal to, a was 2, so it's 2x. I need to select that one, cubed, and then we've got subtract 12x squared, all right, plus 18x, and then it was subtract 5. Okay, so there is our cubic function. Click go. Okay, and so now that has given me this function down here, and I can go here and say find the x-intercepts, and there I have them. All right, so that's helpful there. So I've got the first one is at 0.35821. So coming back up to here, that's this one here. Oh, that's this one here. Okay, and then the next one, which is 1.83174, which is that one. And then the last one is 3.81003, which is there. Okay, and so the time in which s is negative or below the x-axis is up to this first x-intercept and then between these two. All right, so let's just get rid of that. Let's write down these x-intercepts, and we'll just maybe go to x there. All right, cool. So let's see. X-intercepts, we'll say x-ints, 0.35821 ... comma 0, and then the next one was, in fact, let's bring this over here. Next one is 1.83174, comma 0, and then the last one we'll write down here, 3.81103 ... comma 0. Okay, and then have I added ... to that one? No, I haven't. We will add in ... to that. And essentially what that means is that this number is completely unrounded. This number here is just written to the 5th decimal point. And the reason why I'm writing it to the 5th decimal point is just to be overly sure, overly accurate of my final answer. Okay, so there are x-intercepts. All right, cool. So we don't need the calculator anymore. And we know that it's essentially from 0, from t is equal to 0 up to that first one. All right, so s is below 0 for 0.35821 years, and then plus the time in which s is below 0, which is between these two x-intercepts. All right, and the way we can sort of find that out is go brackets 3.8 1.81003 subtract 1.83174. All right, and then now we can, let's put that into here, and so let's go 0.3. Is it going to put in a point for me? There we go. 35821 plus the brackets 3.1003 subtract 1.83174 close bracket equals, and then that gives me an answer of 2.3365 years. And so in conclusion, we'll round that to 3 significant figures. So therefore, S is below 0, aka they are in debt. The student is in debt for 2.34 years. 2.34 years. Cool. And there is the answer to part C.